Hello everyone, good morning. So again I welcome you in this triangle topic. We started understanding about BPT, that is basic proportionality theorem. Yesterday we solved some questions as well as the theorem. Again I repeat what exactly the BPT is. In case if you have a triangle like this, here is A, B and C, and if there is any line parallel to the third side, which may be MN if I consider, then CM upon MA, the vertex opposite to parallel side you can begin with. CM upon MA is equals to CN upon NB. And the same way, the second way to write the BPT is CM upon CA is equals to CN upon CB. So whether to use this or whether to use this, it is up to you. So looking at the question, we can easily understand what exactly I have to use, and that itself I'll be teaching you in this today's session. So today we are going to consider some difficult question, or difficult in sense they are not actually difficult, but compared to yesterday, these questions are a bit difficult. So let's consider these questions and understand it one by one. So today I'm expecting you to complete the question 2 to question 9. All this question you will be completing today. Today I'm expecting you all to send it to me. Okay. So send these questions to me, solve it completely, and the proper way, proper presentation I'm expecting from you, and then you have to send it to me. Clear? Chalo, let's start understanding the questions now. So we'll do it fast as possible because it's not a big deal. So first thing, we'll just prove this part, which is QB, AQ upon QB is equals to AR upon RD. So it's very clear that we have two triangles here. One triangle is above here, I'm just coloring it, and the other one is down here. So in this yellow and green color triangle, now what you can see, I have to use BPT. So let's use BPT. So in triangle ABC, I need to mention lines parallel, that is QP parallel to BC, compulsory. So I get AQ upon QB is equals to AP upon PC, and the reason is BPT is very clear. Then same way, similarly in triangle ADC, we have AR upon RD is equals to AP upon PC, and the reason is BPT. You can easily check this AR upon RD is equals to AP upon PC, isn't it? Simple. Now if I take this as equation number 1 and this is equation number 2, if you look at the equation number 1 and 2, you get the one side of this equation is same. The other one is going to be same. So we have from equation number 1 and 2, AQ upon QB is equals to AR upon RD, and which is expected result as the first one. Now how to get the second one? Check it out. AQ upon AB it is said. So you can easily understand you have to use the second form of BPT, the second type of BPT, right? And process remains same. So you can complete it easily. It's not a big deal, right? I'll go for the next one now. The question number 3, if you check, purposely I'm going fast because I have to cover all these 9 questions in this session. So if I check the question number 3, I can easily understand that it is not a triangle, but still it is given trapezium and 3 lines are parallel to each other, and I have to prove the same thing like a BPT, that is AB upon BC is equals to DE upon EF, right? So what can I do? How can I solve it? So for this I need to a construct here such that I convert this trapezium into triangle or maybe triangles. So one can easily understand that if I join AF intersecting BE at point O, I got two triangles here. One is ACF and second is ADF, isn't it? So considering these two triangles, I may prove the required result. So let's start understanding. In triangle ACF, do we have BO parallel to CF? Yes, all three lines were parallel to each other. So BO, but naturally going to be parallel to CF, right? So I have here AB upon BC equals AO upon OF, and the reason is BPT. Please don't forget to write this BPT every time as a reason. This can be equation number 1. Similarly, in triangle, now here is a important part. ADF, if I check, we have OE parallel to AD. So we have to start from the vertex which is opposite to parallel lines. So I have to start from F. So I can start like FE upon FO is equals to something. FE upon ED is equals to FO upon AO. And reason the same, BPT, and of course the equation number second. When I look at the equation number 1 and 2, I can easily find that somewhere I am finding this area, this part and this part equal, but not exactly equal. They are opposite to each other, or maybe reciprocal of each other. You can check. Here is AO, here is FO, and here is in numerator is FO and denominator is AO. So accordingly, what I can do here, this I will reciprocal. Okay, so how can I reciprocal? Both the side, like ED upon FE is equals to AO upon FO. So in this manner, I am bringing the part equal. This part and this part of equation number 1 it will be equal. So I will consider this as equation number 3. Once I consider this as equation number 3, from 1 and 3, from equation 1 and equation 3, what we get? AB upon BC is equals to DE upon EF, and that's the required result. Hoping this is clear to you. Okay, it's a very simple, same thing we are doing, and rather same thing in throughout the today's session we'll be doing. So you may find these things are very simple. Let's go for the next one. The next one is BE upon BC. You can check. BE upon BC is equals to BC upon CP. Oh, BC upon CP. BE upon EC it is supposed to be. Okay, I'll just make that simple change there. But anyway, once I do it, you will come to know. I think it is supposed to be EC. Please make that required change there. BE upon EC is equals to uh, BC upon CP. Okay, that's it. Let's start understanding. So what I have to do here, let us know. I have to check properly then in which triangle I can use BPT. Okay, so I'll just color that part. Okay, in which triangle I can use BPT, so that you will understand it. This is the triangle where I can see that I can use BPT, and that is very important to understand that कि कौन से lines parallel है and accordingly how to use BPT. So I have already colored that part. Please make sure that you understand it. So in this particular triangle, that in triangle ABC, BE upon EC is equals to BD upon DA. Of course, we have DE parallel to AC. Now all the presentation you can remember and keep in mind. I may not follow it now after this. Now this was maybe one triangle where I can use BPT as equation number 1. There's a one more triangle if you're understanding. I'll just show you that. Another one as well. Without considering what I have to prove, I'm just directly using BPT, and then I will decide how to use BPT, how to use that to get the required result. So this is a triangle where I can use BPT, where the line parallel are this one and this one. So in this line which are parallel, I can easily say in triangle ABP we have BC upon CP. You can check easily, it is very clear, is equals to BD upon DA, and equation number 1. Of course these two are equal, so this and this are equal, and that's it, the required result you have. Okay, so that's what I said, it is supposed to be EC, not BC. Okay, let's go ahead. Question number 5. So in question number 5, what exactly I have to prove is AO upon OC is equals to BO upon OD. Now as we see, okay, these are not a part of a triangle basically, and nothing is given parallel. Rather, things are given parallel, like this is, this is parallel to this. But it is not looking like it is a part of any triangle or any maybe same triangle. So that's why again we expect here the construction. So what can be the construction? You need to remember especially for this question. Okay, mark it as important one, and you need to remember the construction for this. Okay, what the construction is, I have to draw a line parallel from O to AD intersecting at M. So construction क्या हो जाएगा? The construction is draw OM parallel to DC as well as AB, because see DC is parallel to AB already. Again I'm drawing OM parallel to DC, so all three are parallel to each other. Okay, draw OM parallel to DC as well as parallel to AB. Okay, you may say that intersecting AD at M point. Okay, so this is the basic construction, need to remember it. Okay, so I'll start the proof now. What I have to prove here is AO upon OC. So I can choose the triangle such a way that I get AO upon OC. So it is ADC triangle. So I have ADC, right? I have ADC. Now what is there in the triangle ADC? You can check ADC. Okay. In triangle ADC, we have OM parallel to DC. Clear? OM parallel to DC. So isn't it AM upon MD is equals to AO upon OC, which can be BPT? And equation number one. Same thing we are doing. That's the reason I'm taking it so fast. I'm not explaining everything. The next triangle that what I'm supposed to use. So triangle, which is that I'll tell you. ABD. Properly understand. ABD. If you are not understanding, I can just color it. ABD. Did you check the triangle ABD? So do we have OM parallel to AB? Okay, so here what I can get, here I can get a start from the opposite vertex to the parallel line. So we get DM upon MA is equals to DO upon OB. Is this clear? So reason same, BPT equation number 2 and all. So we'll find equation number 1 and 2 carefully, and whether things are equal or not, that I will be checking. So we have this part and this part looking similar, but of course reciprocal of each other. So you know that what can I do? Reciprocal this equation. So I get AM upon MD उल्टा किया उसको is equals to OB upon DO. Okay, this is OB. Okay, so this can be equation number 3. From 1 and 3, what do I get? Understand it. From 1 and 3, what do I get? From 1 and 3, if I look at this equation, I get AO upon OC clearly equal to OB upon DO. And that's it. That's what the required result is. Okay. In your textbook, in the exercise, this question is already there. So what the question is given AO upon OB is equals to OC upon OD. ऐसे प्रूव करने के लिए बोला है. ओके, ये नहीं दिया है, ये दिया हुआ है. नाउ इज इट पॉसिबल टू प्रूव दिस रिजल्ट यूजिंग दिस रिजल्ट? है ये पॉसिबल है? यस, इट इज़ पॉसिबल. आई कैन जस्ट शो यू राइट नाउ हाउ इट इज़ पॉसिबल एंड हाउ सिंपल इट इज़. कुछ नहीं है, ये OC को इधर शिफ्ट कर दो, OB को इधर शिफ्ट कर दो. That's it. AO upon OB is equals to OC upon DO. So anywhere you can shift using the simple algebraic law, and then you can get the required result as well. Clear? Let's go ahead. So next is these two questions. Okay, I don't think I should teach you both the questions. One question I will surely help you in understanding. So this sixth question we will understand. Maybe it is looking bit difficult. तो यहाँ पे मैं फिर से आपको ये समझाने की कोशिश करता हूँ कि कौन से ट्रायंगल में हम लोग BPT यूज़ करने वाले हैं एंड किस वे से यूज़ करने वाले हैं. सी, ट्राई टू अंडरस्टैंड. एवरी टाइम यूजिंग वन पार्ट, दैट इज द फर्स्ट टाइप ऑफ BPT, इज नॉट हेल्पफुल. You have to use the second type of BPT also sometime. So when to use second type, that you will understand right now maybe. So let us see how the question is there with us. So now imagine if this triangle, that is TMC, if I take, is this line parallel to this line? So I'm going to use that as to get the BPT. Now what I need, let us check into the prove that. Prove that में क्या क्या चाहिए मुझे? TX चाहिए, TB चाहिए and TC चाहिए. Now in this triangle I can get TX, but I will get XC, whereas I need TC. So it's very clear that I have to use the second form of BPT to get the TC, right? So now in this question we will also understand how to use the second form of BPT properly. So let's start understanding this question. Now in this triangle, which one is that? TMC. Do we have XN parallel to CM, right? So if it is parallel, so we get Tx upon Xc is equals to Tn upon Mn as a BPT equation number 1. Now you will ask, while saying, you said you have to use second form of BPT and where I'm using the first one. But let me tell you, before using the second form, this is must to be written. You have to write this. So keep this in mind. If I'm using second form of BPT, the first form of the BPT you must mention. Okay, so I have already mentioned that the first form of BPT, and now using this directly you can say therefore second form, that is Tx upon Tc is equals to Tn upon Tm. Please make sure that this is equation number 1, not the first one. Idea clear? You got it? So this is a simple idea I'm giving you. First use BPT with the simple form and then second form. Okay. So losing of marks, or you should may not unnecessarily lose the mark considering the BPT is wrongly used, right? Now the second one. Uh, in triangle, okay, first of all I will just color that triangle if you want. So the which triangle I'm talking about, let me tell you. I'm talking about, now you also must have started understanding it, which triangle I'm talking about. These are the two parallel lines, okay, check करते हैं. Now in triangle, which that triangle is TXM. So in triangle TXM we have BN parallel to XM. So if Bn is parallel to Xm, we get Tb upon Bx is equals to Tn upon Nm, which implies Tb upon Tx exactly is equals to Tn upon Tm. Okay, so visualizing that equation is very important. Visualizing the diagram is very important. So I got two equations which have got at least one side equal. Hope so. Yes, we have Tn upon Tm, Tm upon Tm equal. So what do I get here? After equating these two equations, I get Tx upon Tc is equals to Tb upon Tx. So irrespective of what I have to prove, I just got this something. So now this equation, is it giving us the given result, required result? Yes, it is giving us. So we have Tx square is equals to Tb into Tc by cross multiplying, right? Shifting, you can say. And done, finished. So very simple, right? I'll just erase this part. You can try the second one as well in the same way. Let us check which form I have to use. I'll just help you in that and then we will go ahead. I'm not going to solve this equation. So what I have to prove, I have to get AD, AB and AF in the equation. So it's very clear, as AB suggests us that I have to use second form of BPT. Okay, so it's very clear. I will never get AB in first form of BPT. I hope you understand that. So this AB itself is suggesting us that I have to use second form of BPT, and how to use second form of BPT I have already taught. I'll just show you coloring uh, the two triangles where I can use BPT so that you will get it easily. This is one triangle, FE parallel to DC, and this is second triangle, the complete triangle just made DE parallel to BCA. Okay, so that's the only help I can give you. Next one, I think we have skipped one question. देखो ये 7 था and here we started with 9 question. The reason behind skipping one question is it is HOTS. If you want to try, you can try, but don't consider that question right now. It is HOTS. Later on we are going to work on it. Okay, so let's understand this question. Now in this question, you can see this rectangle there. It's not rectangle, it's sine of 90 degree. Okay, so Okay, now it's a sine of 90 degree. Now what I'm going to do here, clearly lines are given parallel and I can use BPT directly, no issue at all. But I'll just mention the given values in the diagram that in geometry always helpful. So 4 and px upon x cube, ये तो directly given ही है, which I can use in the BPT. I have to find PR and QR. So anyway, I'll use BPT, that is px upon x cube is equals to py upon yr, right? Isn't it? Px upon x cube is directly given, that is 1 by 2. Py is 4. I can get yr, in fact. I'm going to get yr. So what I'm going to do with the yr, let us check. Let us find out. So yr, if I shift here, I get yr is equal to 2 4 is 8. Right? So yr will be equal to 8. But nowhere in the question it is asked yr. So I have to find PR. So can I find PR using yr? Yes. PR is equals to py plus yr, which can be 8 plus 4, which is 12 in it. And once I get that, once I get 12 as PR, I have to find out now QR. Check कर लो. Now how can I find QR? Because your BPT, you must have realized till this time, nowhere BPT tell us about XY and QR. It always works with the other two sides than these two sides, parallel sides, right? Now that is the basic problem of BPT, that it never tells you about the parallel lines. But whereas in the question we are asked for it, so that means it is very clear that I have to use something other than BPT. So what I have to use BPT, this right angle symbol itself tells us it's nothing but Pythagoras theorem. So using Pythagoras theorem, I get PR square is equals to PQ square plus QR square, and you can use this one to find QR because you have all other values. That's it. Isn't it? It was very simple thing. Okay, so let's go for the next one. Here is the next one and maybe the last one for this one. Let us check. Yes, it is the last one of BPT. Okay, so let's complete it as early as possible and as quick as possible. Now here, quite confusing, isn't it? It's really confusing. So let us see how can I reduce the confusion. The confusion can be reduced only by looking at the parallel signs. Okay, so when you look at the parallel signs, you can easily get the BPT. To use that BPT, however it is useful or it is not useful. Okay, use BPT first of all. So I'll just help you in detecting parallel lines. So here is my CB parallel to QR. Using only this, is it possible for you to write a BPT? So I can write it without any presentation. I'm working. You have to work on the presentation because you have to send it. Send this to me today. So it is PC upon CQ. I'm using the first form because I can get the separate values here. I can see that PC upon CQ is equals to PB upon BR, right? So I can easily put the value. PC is X, CQ is 15, we have PB as 15 again, and BR as Y. So this is equation number 1. And when I see these, I can easily understand that X and Y as both the variable are unknown to me. Accordingly, I cannot use this right now. So clearly, I have to use the second way. तो second way के लिए मैं फिर से क्या करता हूँ, I'll just try to erase this and draw the other two parallel lines. These are the parallel lines. You can check here, right? So if these are the parallel lines, so I can use BPT. I'll start always with the opposite vertex to the parallel line. So it is QA upon AR is equals to QC upon CP. I can put the value QA as 12, AR as 20, QC, CQ as 15, and CP as X. Now when I look at this equation, it's clear to me that X I can find by shifting. So 15 into 20, 20 upon 12. So it is 3 5s are 3 4s are 12, 4 1s are 4 5s are 20. So it's very clearly giving us X is equals to 25. Now you will say, then what is the use of this? I can put now the value of X in this and I get 25 upon 15 is equals to 15 upon Y, which can give me easily Y is equals to 15 into 15 upon 25. So 5 ones are 5 5s are 25, 5 3s are 15, and 5 ones are 5, 5 3s are 15. So y is equals to 9 in it. And here is the answer. So I am hoping that you are clearly understanding all the all the maybe I think 7 questions. So from question number 2 to question number 9, I want you all to send it to me today. If you're not sending, I have to forcefully call you back. Today you have to watch this video. So what time I'm giving you? 9 p.m. Okay, so it is evening, night, 9 p.m. Before that I want all these things to me. Okay, you have to send it to me. Fine. Clear. So I hope all these things are clear to you. Question number 8 is HOTS. We have skipped it, so it's not a big deal. 2 3 4 5 6 7 and 9, the only 7 questions, let me tell you. Just 7 questions, you will be completing it and sending it to me with proper presentation. Diagram not necessary, not required. If you directly solve it without drawing diagram, then also it's okay. On the question number you have to mention. Hoping you all have got the PDF. Look at the PDF and complete this question. There is one rectification in the question number, I think, to just a minute, third question, fourth question, sorry. The fourth question, there is a mistake in the question itself, so that you can rectify using this particular sheet. So thank you so much. Bye bye, see you tomorrow.